Hello, Math 2 students, and welcome to your adding and subtracting and multiplying radicals video. So let's go ahead and get started. It says to add or subtract radicals, you must have like radicals. Like radicals are radicals that contain an identical radicand and identical index. So what do they mean by that? They mean that they have to have the exact same thing inside of the radical and the exact same radical. So let's see, if we look at this first example, these both are square roots, and they both have a 3 inside. So these are like radicals. So yes, they are like. Now let's go ahead and check out the next example. So we've got the square root of 3, and then we've got the cube root of 3. Now notice they have the same thing inside of the radical, but the root of the radical is different. So these actually are not like. And the reason for that is because of the root. And if we look here, we've got root 3 and root 2. Again, these are both square roots, but what's on the inside is different. So these are not like either. So to reiterate, you have to make sure that you have the same root and the same thing on the inside. So they call that the radicand and the index. So the radicand is what's on the inside, and the index is the small number. All right. So let's go ahead and try the example A here. It says if you have like terms to add or subtract, just add or subtract the coefficients and keep the same radical expression. So really the way that you treat radicals is when you're adding and subtracting them, you treat them just like variables. So like think about like if we had 3x plus 5x, that's going to give us 8x, right? That's pretty much what we're doing here. So we've got root 11, so we're going to combine these guys. And then we've got root 3, so we can combine those guys. So we're going to do 5 minus 8, which is going to give us a negative 3 root 11. And then we've got 6 minus 19, which is going to give us a negative 13 root 3. All right, so let's go ahead and try number 2. So again, you are going to treat these radicals, these like radicals, as kind of as if they were variables. So think about like if I had 8x plus x. Well, what would that equal? That would give us 9x, right? So here, if I have 8 root 2 plus root 2, that's going to give us 9 root 2. It's not too terrible. All right, let's go ahead and check this one out. Again, we've got two like radicals, the root 5 and root 5. Root 5 minus 10 root 5 is going to give us a negative 9 root 5. And if you ever get confused, just think about, well, what if I had x minus 10x? Well, that would give us a negative 9x, right? Same thing going on here. All right. And then root 6 minus root 6, well, that's just 0, right? If you have root 6 of something, you take root 6 away, you got 0 left. All right. So now things get a little bit more complicated. And the reason for that is we have to see if we look at these radicals and they are not like, right? They aren't similar. We have to see if we can make them similar, okay? So let's see if we could break apart root 8. So 5 root 8, we can break down 8 into 4 and 2, right? And take that 4 out because 4 is 2 squared, so we can take a 2 out. We get 10 root 2. All right. Then this root 18, we could break down into 9 times 2, which is the same as 3 squared times 2. So we'd have plus 3 root 2. So basically, I simplified these radicals, and now I've got similar radicals, right? So I can go ahead and combine those, and I get 13 root 2. Let's go ahead and try another one. So again, we have to try and simplify these radicals. So I can break 12 down into 4 times 3. So that's going to give me 8 root 2 squared times 3. So I'm going to pull the 2 out, and I get 16 root 3. Right, I did the 2 times 8, got me 16. And then 48, I could break down into 16 and 3. So I'm going to have minus 5 root 4 squared times 3. So I can take my 4 out, and I get minus 20 root 3. Now we're all happy. We've got like radicals, so we can combine those guys, all right? So we'll go ahead and combine these. We get 16 minus 20 is going to give us a -4. So we get -4 root 3. So hopefully, you're kind of picking up on what we have to do here. Hopefully it's not too challenging. Let's go ahead and try and break this one down. So we've got root 24. I would break that down into 4 times 6. So we got 2 squared times 6, which is going to give us, we're going to pull our 2 out. So we get 6 root 6. Root 54 is going to be 9 times 6. So we've got root 3 squared times 6. We're going to pull our 3 out. 6 root 6 minus 3 root 6 is going to give us 3 root 6 is our final answer. All right. So go ahead. Let's try and break this one down. So we got root 125. We could break that down into 25 times 5. So we've got 4. 5 squared times 5 minus, and then we can go ahead, pull our 5 out. We get 20 root 5. And now we've got root 80. So for 80, we're going to want to break that down into a 16 times 5. So we've got 9 root 4 squared times 5. We can pull the 4 out, and we get -40 root 5. So we'll go ahead. Now we've got our like terms, so we can do -20 root 5. All right, last one. So we can go ahead and see if we can break 12 down. So 12 we can break down into 4 and 3. So we're going to have 7 root 2 squared times 3. And then we can break 8 down into 4 times 2. So then we would have do -8, 2 squared times 2. So we'd end up with, pull our 2 out here, we get 14 root 3 minus 16 root 2. So notice here, we actually do not have like radicands here, right? We've got a 3 and a 2, so this is actually the most we can simplify that. All right, so on to part C here. So it says, decide whether it is true or false that the expression is fully simplified. If it is false, correct the error. So if we look here, for number 1, it says 5 cubed root 8 minus 4 cubed root 8 equals cubed root 8. So this statement is true. However, they're asking, is it fully simplified? So if we look here, this actually is not fully simplified. Cube root of 8 equals 2. So this one would be false. To fully simplify it, we would need to get it down to 2. All right. Then here for number 2, this one, we have 2 different radicands, right? And you can't simplify them at all, right? You can't pull anything out of the, you can't pull anything out of the 5, which means that you cannot combine them. So this is true. You cannot simplify this anymore. All right. Then for this one, what we need to do is we need to see if we're able to simplify these further. All right, so for 18, we could break that down into 9 and 2. So we'd get 7 root 3 squared times 2. We bring the 3 out, we should get 21 root 2. And then the 50, we're going to get 25 and 2. So we get 2 root 5 squared times 2. We can bring our 5 out. So we would get 10 root 2. And notice now we've got the same radicand, so we can combine those. So we'd get 31 root 2. So this one was false, and this was us simplifying it further. All right. So here they simplified it down to root 10. So let's see if this is true. Can we simplify this down to root 10? So here we've got root 90. So we could break that down into 9 times 10. We can't simplify the 3 root 10 anymore, so we're going to leave it as 3 root 10. And then, of course, we've got 3 squared times 10. We've got 3 root 10 minus, and then we bring a 3 out, so we get 3 root 10. Well, 3 root 10 minus 3 root 10 actually is going to equal 0. That's like if you did x minus x or something like that. So the statement is false, right? Our answer here should be 0. All right. So now the last thing we need to know how to do here is multiply radicals. So they tell you how to do it here. It says multiply the coefficients, multiply the radicands, and then simplify completely. So what do they mean by that? Multiply the coefficients, then you multiply what's on the inside there. So 5 times 2 gives us 10. 3 times 7 gives us 21. Then once you do this, you want to see if you can simplify this radicand. You actually cannot pull anything out of 21. The only factors are 1, 21, 3, and 7. None of those are perfect squares, so we're done there. And the next one, multiply the 4 and 5, you get a 20. Multiply the 6 and 2, you get a 12. This one you can simplify further. You could break 12 down into 4 times 3. So you've got 20 root 2 squared times 3. You can take the 2 out, and you get 40 root 3 as your answer there. All right, so then for this one, we're going to go ahead and multiply. We get 2 times 3, which gives us 6. 8 times 5, which is going to give us 40. Then we'll go ahead, we can break that down into 4 and 10. So we got 6 root 2 squared times 10. We can bring our 2 out, and we get 12 root 10. And that would be our answer there. So to reiterate, all you do, multiply the coefficients, multiply the things inside of the radical, and then you see if you can simplify the radical further. So remember in 1, we weren't able to simplify the radical further, but here we could. We were able to break down the 12, break down the 40.